There we are. Adam, if you'd like to take over.
Thank you, Joe. Hi, everybody. Can we go to my first slide, please, Anne? Well, thank you. So this is, I've chosen a couple of examples of image registration to talk about, which are maybe not the standard examples, to highlight some of the different ways in which we might choose to use image registration. One reason I chose this is that it's still one of the high points of my academic career. This is when we got the chance to image some drawings by Leonardo da Vinci. And what I'm showing here, I'm flashing between two images, one taken in the green, where you can see the horses at the top, and the other is a fluorescence image taken in the ultraviolet, but excluding the source, so you're only seeing the fluorescence light. And that's where you see the other images and the dog at the bottom. This was just for interest, just for public engagement and viewing, if you will. So the image registration here I did by eye in Photoshop. So that when Joe was asking about the how, this is just by Photoshop. And when he was asking, is it good enough? Well, it is good enough because it shows that the horses are there at the bottom in one and they're not there on the other. We're not after pixel alignment here. This is just to illustrate the fact that some of the illustrations are visible under the naked eye and some aren't. Can I have the next one, please, Anne? Thank you. This looks a mess, but I hope you can work out what it is if I explain it. What we've got here is pictures of some watercolour drawings of the aldermen of the City of London, held by the London Metropolitan Archives. And they've got a lot of these images. And they wondered whether there was a standard template that was modified whenever a new alderman came in to get his own picture, or whether they were done bespoke for each new alderman as he arrived. And so we imaged these and registered them such that, and then what you see here is one image in green and another image in red. So that when they align, you see the outline in black. And what you can see is that some of the lines are black, which means that they're common to the two images. Others are in green or red, which means they're not. So this allows us to look at which parts of the drawing are similar in the two cases, and therefore which are likely to be part of a template. The image registration problem here is quite severe because some of the, we've heard before about if you're registering a visual image to an X-ray image, for example, some of the features might disappear. Here you've got effectively got images, you've got features appearing in the wrong place. You know, his hat is different depending on how it's drawn. So some of the features are appearing and disappearing, and some of them are appearing in the wrong place. We still want to get some registration for the features that are in common. And Keris Jones was the PhD student here who did this, and she ended up using a phase contrast form of image registration, which aligns in the frequency domain rather than the spatial domain. The details of it are in the paper there. So again, is this good enough? We're not necessarily wanting or able to get pixel by pixel precise registration here. What we want to know is whether this line is likely to be the same in two drawings or not. So the alignment is important, but the precise alignment is not quite so important. My last slide, please, Anne. And here I've just left you with some references and a reminder to me at the bottom that we aren't the only people to be tackling this problem. Certainly image registration is a very big deal in medical imaging, where maybe the images are not such high resolution. So the challenges are similar but different. But across science, there's a lot of people looking at image registration, and we probably shouldn't be trying to solve problems that have been solved elsewhere previously. Thank you, Joe. That was all I wanted to say.